Welcome back, guys, to our DSA challenge series. This is the phase 4 of our series, and the questions that we are tackling in this series are based on stats. The question that we are going to look today is maximum score of a good subarray. The question says you are given an array of integer nums, 0 index, and an integer k. The score of the subarray is defined as the minimum of if the subarray is from I to j, then we need to find the minimum of nums at the index of I till nums at the index of j and j minus I plus 1. So this is the score of the subarray defined in the question. A good subarray is a subarray where k lies between I and j. We are provided an integer k in the question itself, and the k should lie between I and j. We need to return the maximum possible score of a good subarray. Now let us understand this question with the help of an example. We were given an array nums 1, 4, 3, 7, 4, 5. The value of k which was provided to us is 3. So the maximum possible score of a good subarray that can be returned from this particular example is 15. Because the subarray that we have chosen is 1, 5. So among the numbers 4, 3, 7, 4, 5, the minimum is 3 and the value of j minus I plus 1 is going to be 5 minus 1 plus 1, which is going to be 5. So 3 into 5 is 15. This is the maximum possible score that we can get of a good subarray. So I hope the question is clear to you. Let us see it with one more example as well. The subarray which was the array which was provided to us is 5, 5, 4, 5, 4, 1, 1, 1. The value of k is 0. So the optimal subarray is 0, 4 because our I, j should lie between, the k should lie between I and j. K, it is clearly mentioned that k is greater than or equal to I and lesser than or equal to j. So the subarray which is possible is from 0 to 4, then the minimum number is 4 and value of j minus I plus 1 is going to be 4 minus 0 plus 1, which comes out to be 5. So the maximum possible score of a good subarray is 20. So I hope the question is clear to you all. Now let us see the code of this particular approach. What we are going to do is we are going to initialize the result variable res and the minimum variable mini to the value at index k. The idea is to start with k as the midpoint of the subarray. So what we did in line number 4 and 5 is we have initialized the variable result variable res and the variable mini with the value at nums at the index of k. Secondly, we have initialized two pointers I and j, and we have both initially set to k. These pointers will help us to expand the subarray. So in line number 6 and 7, we have made two pointers I and j, and we have set them to k, which was already provided to us in the question. Then in line number 8, we have calculated the size of the subarray of the array which was provided to us. So these were the initial steps. Now then what we did is we have applied the while loop. While one of the pointers I or j is not at the boundary of the array, if I is at the left boundary, if I double is equals to 0, it means I is at the left boundary. Then what we are going to do is we are going to increment the value of j. Else, if we are going to check if j is at the right boundary. To check for the right boundary, we have applied the condition j double equals to n minus 1. If j is at the right boundary, then what we are going to do is we are going to decrement the value of I. Or if the element present at a at the index of I minus 1 is smaller than the element at a at the index of j plus 1, then we are going to increment j to expand the subarray towards the right. So we are checking that particular condition. If nums at I minus 1 is less than nums j plus 1, then we are incrementing the value of j in order to expand the subarray towards the right. Otherwise, what we are going to do is we are going to expand the subarray towards the left. So that is why we will decrement the value of I. Once all the conditions are satisfied, we are going to update the value of mini with the minimum element between I at the index of I and I at the index of j. After that, we are also going to update the value of the result variable which we have made with the maximum of the value mini into j minus I plus 1, which was the condition specified in the question. So once the entire loop will get completed, we are going to continue the process until any one of our pointer reaches the boundary. As soon as a pointer reaches the boundary, so this condition will become false. I greater than 0 and j less than n minus 1. If any one of them will reach the boundary, so the loop will terminate. And after that, we are going to return the value of the result variable. So this is the approach which we are going to follow in this particular question. The time complexity of this approach is going to be big O of n, where n is the length of the input array A. This is because we are going to traverse the array from left to right only once. So I hope the question is clear to you all. If it is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.